Alright, first problem here, we want to find the general solution to a linear equation with constant coefficients. The way to do this is to solve the corresponding characteristic equation, which in this case is r squared plus 2r minus 15 equals 0. This one factors. This is r plus 5 times r minus 3. So we got two roots, negative 5 and positive 3. So we got two distinct real roots, and that means that our general solution is going to be a combination. It's going to be a linear combination of e to the negative 5x and e to the 3x. So it's going to be c1 e to the negative 5x plus c2 e to the 3x. Okay. Number two, same deal. You want to start off by solving the characteristic equation, which in this case is r squared plus 2r plus 1 equals 0. This one factors as r plus 1 squared equals 0. So you have one repeated root here. The root is negative 1. And so if you have a real repeated root, the solution looks a little different. It's going to be c1 plus c2x e to the, and the power is going to be negative 1 times x. In other words, negative x. Okay, so that's what it looks like if it's a repeated root. Okay. Number three, we want to solve an initial value problem. Okay, notice it's the same equation as in 2. So we know what the general solution looks like. We just need to find C1 and C2 that satisfy these two initial conditions here. So let's see, first of all, notice that the fact that y of 0 equals 2, if you just plug in x equals 0 here, what you'd have c1 plus 0 times e to the 0. So you have 2 equals c1 plus 0 times e to the 0, and that means that c1 is 2. Okay, so actually we have y equals 2 plus c2x e to the negative x. Now finding c2 is going to be a little trickier because we have to find y prime, and in order to find y prime you would need to use the product rule here. So y prime would be what? It'd be the derivative of, so the first function is the thing in the parentheses. So it's the derivative of the first times the second plus the first times the derivative of the second, and the derivative of the second is minus e to the minus x. So that would change that plus to a minus, actually. That's the product rule. Okay. Now the fact that y prime of 0 equals negative 1, that means that negative 1 is equal to what happens when I plug in x equals 0 here. So that would be c2 e to the 0 minus 2 plus 0 e to the 0. So in other words, negative 1 is equal to c2 minus 2, and that means that c2 is positive 1. So our actual solution here would be y equals 2, I'm just going to plug in c equals 1 back up here, or c2 equals 1, so yeah, so it's 1x, so it's just x, like that. So that's the solution to that differential equation, which also satisfies those two initial conditions.